Question 1. Write these numbers in order of size, and it says to start with the smallest number. So if we look at these numbers here and we put them on a number line, then we know 0 is going to be here, 1, and then if we want 4, then we're going to have 2, 3, well there's 4, and then the negative numbers, well if that's 0, then we have negative 1, negative 2 will be there, and then negative 4 will be here. So that number line will help you, and if you put them in the order of size, starting with the smallest first, you can see it goes negative 4, then negative 2, 0, 1, and then 4. Question 2. There's 4 cards that you're given, one labelled 7, another one 8, 4 and 9, and you have to make the largest 4-digit number that can be made using each card only once. So if we've got 4 cards, a 4-digit number, then we can have the units, the tens, the hundreds and the thousands. So ideally, to get the largest number, we want the most thousands that we could possibly get. So we're going to put a 9 here, and then ideally we want the most hundreds we can possibly get. We can't use the 9, we've already used it, so we'll then use the 8, and then so on. The most tens, but we can't use the 8 and the 9, so we'd have the 7, and that leaves us with 4. So the answer would be 9,874. If we had to make now the smallest 4-digit even number, that can be made using each card only once. Well, be careful, because when I first looked at this question I thought you could just reverse the numbers and have 4,789, but that would be an odd number. So what we can do is, we've only got 2 choices for even numbers, an 8 and a 4. So be very careful which number you end it with, because if it ends in a 4 it will be even, and if it ends in an 8 it will be even. So we'll do the hundreds, tens, units, and then we've got the thousands here, and we'll try and say to ourselves, okay, we've got to choose from a 7, an 8, a 4 and a 9. So we want the smallest 4-digit even number, so we want to have the smallest amount of thousands we can possibly get. So that's definitely going to be starting with the 4 here. So if you think about it, to make the number even you'd have to end in an 8. So that's those 2 gone. Then think about it. If you've got the hundreds here, you can either have 700 or 900. Well, to make it the smallest, you'd choose 700 here. And that only leaves you one choice left, which is the 9. So it's actually 4,798. So it's very similar to what I first thought, and all I had to do was really reverse these 2 here, and I would have got the answer 4,798 exactly the same way. Question 3. Write 7/20ths as a percentage. Well, percentage means out of 100, or for every 100. So if we have 7 out of 20, then we know that we can make fractions seem to look different but have the same value by multiplying or dividing the top and bottom number by the same thing. So for example, if we times the top number by 5 here, we'd have to do exactly the same to this one. And the reason behind that is, if I times something by 5 and divide by 5, 5 divided by 5, which is what you'd have as a fraction here, is actually have the value of 1. So it's like doing 7/20ths times 1 whole one. So I could have, for example, times 7/20ths top and bottom by 8. Because 8/8 is 1 whole one, and if I times something by 1, its value doesn't change. So coming back to this one here, I times top and bottom by 5 because I knew if I times the 20 by 5, I'd make the 100 straight away. So because I've got 7 times 5 on top, I know that 7/20ths is actually 35 out of 100. Now, if you were to times 7/20 by, say, the top number by 2 and the bottom number by 2, that would be allowed, but you'd get 14 out of 40, which is not a percentage, because to be a percentage it would have to be out of 100. Question 4. Work out 20% of 54. Well, if we know that 10% of £54 is £5.40 and 20% has to be double, then we could say £10.80 and that's finished, and that would be the answer. Another way of looking at it is we could do 20% is 20 over 100 because it's out of 100 of, which is times 54. And we should know that 20 hundredths is 2/10, so 2/10 of 54 would be the same answer. And we also know we can halve the top number and halve the bottom number, so we could actually do 1/5 of 54. And if you did 1/5 of 54, that's the same as 54 divided by 5. So 5s into the 5 is 1, 5s into the 4 doesn't go as a whole number, so remainder of the 4, and 5s into the 40 is 8. So as we're talking pounds, it'll be £10.8, or better still, £10.80 again. So this method here is quicker. This is slightly slower. There's one other method as well, which is helpful when you're doing something on a calculator, and that is you can just times 20 by 54. So if you do 20 times 54, well, 2 times 54 is 108, so 20 times 54 is 1080. And then because it's a percentage, this number here was out of 100, so you can then just divide this by 100 and you would have got the same answer, 10.80 or £10.80. So I think for the exam here, working with 10% and then finding 20% is probably the better way for this question. Question 5. There's a grid drawn with x and y axes, and on the grid you have to mark with a cross the point -2, -3. So we go -2, -3, so it'll be here. So it wants the cross, so there it is, and label it C. There you go. And it says write down the coordinates of the midpoint of AB. So if I have this line segment here from A to B, and I want to find the coordinates of the midpoint, well, the midpoint will be halfway. So if you went forward one here, then you'd have to go forward one here. If you went forward another one, and then another one, so halfway would be this point here. So to write that coordinate down, to get there, you'd have to go back 1, up 2. So back 1, up 2, and that would be the coordinate of the midpoint. Question 6. It says the pen costs 32p, a pencil 8p, and it tells you a ruler here for some reason, but you don't need that for this question. It says she has to buy the same number of pens as pencils, and what's the greatest number of pens that she can buy, and she has £15 to spend. So I think what I would do is I would have a pen and a pencil, and I'd have the costs here. So I know that if I add those together, I've got the same number of pens as I have pencils, i.e. 1 and 1, and that would give me a total of 40. So I can never change the amount of pens and pencils I have in terms of being different from each other. So if I know how many 40s go into £15, so i.e. 40 pences go into £15, then I can have a good go at working it out. So I'm going to take my £15 and convert it into pence. So that's 1,500 pence divided by 40 pence, which is the cost of a pen and a pencil together. So I'm going to divide top and bottom by 10, so that's the same as 150 over 4, and then I'm going to halve the top and halve the bottom, so that's 75 over 2, which is 37.5 times. So you could buy, for example, 37.5 pens and 37.5 pencils, and that would be exactly £15, but we know we can't buy half a pen. We've either got to buy one or not. So if 37.5 is exactly right, you can't buy 38 because you just wouldn't have enough money, so you'd have to buy 37. So the answer here would be 37 pens. Question 7. It gives you the ages of 16 men, and you have to complete the table to show the information. So we'll go through one of these at a time. So 28 would be in here, 30 and 40, 37, 35, 31, 29, 39, 34, 33, 35, 28, 40, 29, 27. Now be careful, you strike that through like that, so this should be a little bit larger here, so that's 5, and 35, again, strike that through, that's the tally. And now we can count the frequencies. Don't forget they should add up to 16, so we've got 4 here, 2, you see I've made a mistake already, it's not 4, it's 5. So it just shows you how easy it is to make a mistake. So 5, 2, 5, 1 and 3. Just check that up to 16. 5 and 5, that's 10, 12, 15. So that's all sorted out, that's 16. Now we've got to, on the grid, draw a suitable diagram or chart for the information in the table. So here I would label this as age and this as frequency. We'll do the frequency scale first. So we'll probably go up in 2s here. So 2, 4, 6, 8 and 10. I'll then label the age axis as shown, and I would just do the labels here. And then I'd make sure that when I do the bars, so let's start doing them. So we have a frequency of 5 for the first interval. Let's see what we'd have here. Frequency of 5. The next one will be frequency of 2. And it's important that these bars touch side to side. And the simple reason for this is that age is continuous, so there's no gaps. So from turning 29 to turning 30, there's no gaps in between. So although up to here you're 29 years old, you could have been very, very close to 30. And to be in here, you could have just been 30. So we can just do the rest of the bars here. So 5, and that's 33 to 35. And the next one, 1. And then finally 3. Okay, so there's our suitable diagram or chart for the information in the table given. Question 8. The stem and leaf diagram shows the information about the heights in centimetres of the boys in a class, and it gives you the key here of how to read it. Now we want to find the median height. So if you think of them being all in size order, from smallest to largest, then we want to pick the middle one once they've been put in order. So if we start from the smallest one and work outwards, so we'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So there's 21 heights registered in that stem and leaf diagram. Now, if we had 21 heights in order, we'd have 10 this way, 10 this way, and we'd have one in the middle, i.e. the 11th. Okay, so if I start counting from the smallest and get to the 11th, that will be the median height. Because don't forget, this is an ordered stem and leaf diagram. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, there it is there. So it would be 165. If you started counting from the largest, you'd have to work from your outside inwards. So you'd have to go 1, 2, 3, and then 4, 5, 6, 7, 8, 9, 10, 11, and you'd get to the same place, 165. So just be careful how you count. The next part of the question says, the girls in the class have a median height of 162 centimetres and their heights have a range of 45 centimetres. It says compare the distribution of the heights of the boys with the distribution of the heights of the girls. Well, if we wanted to compare the distributions, then if we did boys here and girls, and we look at median first, then from our information we worked out the median height for boys was 165 centimetres and for girls it's 162. And then the heights of the girls has a range of 45 centimetres. And we can quickly work out the range for the boys, and it goes from 140 being the lowest up to 181. So the range is 41 centimetres, the difference between 140 and 181. So we can just compare the distributions by saying the boys have a greater median height, and you can put brackets 165 centimetres, although the girls have a greater range of height, and you can put that down as 45 centimetres. Okay, so you have to write full sentences and you have to kind of give the figures as well, and that should get you the marks for that question. Question 9. The formulae below can be used to work out the cost C pounds of a taxi journey of X miles with 3 different taxi companies. So Reliable Taxis has a formula C is 1.5x. The next company has one C equals 1.1x plus 11.5, and the last company, City Taxis, has C equals 1.25x plus 8. Well, if we want to go 30 miles, then we've got to attempt to substitute x for 30 in each of these. Okay, so in option 1, we'd have 1.5 times 3, but 10 times as much. So 1.5 times 3 would be 4.5, but if we want to times it by 30, it would be 4.5 times 10 again, so that would be £45. Another way of looking at it is we can do one lot of 30 and then we can do half of 30 and add it on. So a whole lot of 30 is 30, a half of 30 is 15, and we could put those together and get 45. For the next company, Speedy Taxis, we would have 1.1 times 30. So think about that. Well, 3 times 1.1 will be 3.3. So 30 times 1.1 will be 10 times more than 3.3, which will be 33 plus the 11.5, and that would give us £44.50. Okay, if you're not sure, just write these in columns and then you can just add them up. Okay, and you'd get £44.50. Now for the last company, you'd have 1.25 times 30 plus 8, which is all in pounds. And one way of doing that is, you can either say 1.25 is 1 1/4, and 1 1/4 is 4 quarters and 1 more quarter, which is 5 quarters. And then you can say, okay, 5 times 30 is 150, and then divide it by the 4. Well, 150 divided by 4 is 75 over 2, which is 37.5, and 8 will give us 45.5 or £45.50. So we've got to work out which is the cheapest, and it seems that the cheapest will be Speedy Taxes here at £44.50. So we'll write that as cheapest and put a little ring around it so we can see what the answer is. Okay, so £44.50 is the cheapest. There are other ways of doing this, but without a calculator, just try and show all your workings and make sure you definitely outline which one is the cheapest. Question 10. We have a picture of a kite labelled as A, and it says translate that shape by the vector 6, -5. So when we're looking at a translation in terms of a vector, this tells us where to go on the x and then on the y. And each point or each vertex has to move 6 along, down 5. So if we start with this point here, we can go 1, 2, 3, 4, 5, 6, and then down 5, 1, 2, 3, 4, 5. So that point's going to be there. The shape's still going to look exactly the same, so it's quite easy then to work out what the shape's going to look like when we finish. Okay, so a very bad diagram there for me, but you get the idea. If you're not quite happy with that, take this point, if that was a tricky one, go 1, 2, 3, 4, 5, 6, which is the top number here, and then down 1, 2, 3, 4, 5, and you can see it there. And it says label that new shape B. Okay, so I'll try and do the next shape a little better than that one because that looks really messy. And it says on the grid, translate the shape B by the vector -8, 8. So this means go back 8 and then up 8. So this is along the x, so we want to go back 8 first. So 1, 2, 3, 4, 5, 6, 7, 8, and then up 8 here on the y. So 1, 2, 3, 4, 5, 6, 7, 8. Now the shape will still be preserved, so it'll be exactly the same shape. It will look the same. It's not being rotated or reflected. This is the tricky point here. So you could always do that one again from the start if you want. And we're going to label that one as C. Then it says, write down the column vector for the translation that maps shape A onto shape C. So we just want to go from A to C really. That's all it's saying. So we're going to go pick a point and we're going to say, right, back 2, up 3. So back 2, up 3, and that should work for every single point that we choose. So we'll choose this one. So back 2, 1, 2, up 3. Okay, so that would be the translation column vector. So question 11, we've got to simplify this expression. So let's have a look at the x's first. We have 1, 2, 3x, so we have 3x, 3 times x, and then we have 2y, so that's and 2y. So 3x plus 2y, or 2y plus 3x would be the simplest version we could make of that expression. Part B, let's look at the p's first. So we have 3 of them here, and we're taking away 1 of them here, so we're going to end up with 2 of them, so 2p. And then looking at the q's here, we've got 7 of them, and then we're putting that together with -4 of them. So 7 of them with 4 of them taken off, or leave 3 of them. So 2p plus 3q would be the simplified expression for what we had. Now we've got to expand, and it says we want 2m minus 3 multiplied by 6. So one way of thinking about it here is to write this out 6 times, which seems a bit silly to start with. So if you know the idea, then just zoom forward. You don't have to watch this part. So there we go. We've got 6 of them. And then you can do like an adding sum here. And you can say, well, I'm taking away 3, 1, 2, 3, 4, 5, 6. I'm actually taking away 18 altogether. And then how many m's would I have? Well, 2, 4, 6, 8, 10. I've got 12 of them. One way of looking at this is that whatever's inside the bracket, you have to multiply by the number outside of the bracket. It just means 6 lots of what's ever inside the bracket. So we'd have 6 lots of 2m, which would give us our 12m. And then 6 lots of 3 gives us our 18, but we had 6 lots of negative 3. So think of it as a debt of £3, and I wanted to have 6 of those debts. So imagine 6 bank accounts all had £3 debt in them. How much debt would there be altogether? Well, there'd be £18 worth of debt, therefore negative 18. One other way that students can do is a grid, and you can write 6 here, 2m minus 3, and you can just multiply them through. So you can do 6 times the 2m gives 12m, and then the 6 times by the minus 3, which will be minus 18, and so you've got 12m. Let's write that properly. So you'd have 12m minus 18. This one asks us to solve 7f plus 6 equals 27. So the first thing we can do is take 6 from both sides, so it balances, and we'd be left with 7f equals 21. Now I want to find the value of f. That's what I want to solve for the unknown here. So to solve for f, I would have to find what one of them was worth. Now 7f means 7 times f is 21. So if I want to find the value of one lot of f, I would have to divide both sides by 7, or make it 7 times smaller on each side. So that would give me f equals 21 over 7 would be absolutely fine. But if you know that's 3 and you can see that, then you can write equivalent to, that's what 3 dashes mean. Slightly different from equals. So it's going to be 3. So f is going to be 3, and then you can write, let's write this properly, you can write f equals 3. Question 12. It says 60 people each took a driving test one day, and it said 21 of these people were women. So that would leave 39 men. It says 18 of the 60 people failed their test. Okay, so we know that these have got to add up to 18. And it said 27 of the men passed their test. So if 27 of them passed, then there was only 12 left to fail. And because these two had to add up to 18, because there was 18 people who failed altogether, this would have to be 6 here. And then we know as we had 21 here and we have 6 here, then that would leave us with 15, because only 15 and 6 would give us the 21. So that's that filled in, the frequency tree. I haven't seen a frequency tree before, I have to say, that's the first, but I've seen one now. It says one of the men is chosen at random. Work out the probability that this man failed his test. So we'd have to go along here. So out of the 60, we would have 39 men. So that's what we're choosing from. So we're working out the probability that a man has failed his test based on one of the men being chosen at random. So it's going to be out of 39. And all we've got to do is just read how many failed. So 12 out of 39. You can cancel that down if you want. I always feel in probability it's best not to cancel down, but if you wanted to, you could say that 3 times 4 is the 12, and 3 times 13 is 39, and then you can divide both sides by 3, so we'd have 4/13. You could say that as well. But 12 out of 39 is just as good. Question 13. There's a shape made from 2 rectangles and you have to work out an estimate for the total area of the shape. So I'm going to do all of this to the nearest centimetre. So this will be 2 by 2, so that would give me 4 centimetre squares. And this would be 7 by 5, which would be 35 centimetre squares. So an estimate that you could use would be 35 and 4 would give us 39 centimetre squares. Then you've got to answer this question. Is your answer to part A an overestimate or an underestimate? Give a reason for your answer. Well, looking at this area here, I rounded both of the numbers here down. Okay, so 4 would be an underestimate. And also, I rounded 7.37 down to the nearest whole number. So that's closest to 7 than it was 8. So I rounded that down, and I also rounded this one down. So in both occasions, I rounded downwards. So my estimate of 39 would be an underestimate. So an underestimate, and you can write the sentence yourself. Question 14. It says, a cafe sells cakes and scones, or scones, depends how you want to say it. It says on Tuesday, the ratio of the number of cakes sold to the number of scones sold was 5:2. So let's write that down. 5:2, and that is cakes to scones. And on Tuesday, the cafe sold 80 of these scones. So if we want to end up with 80 here, we've got to just work out the number here. So with ratios, you can kind of treat them like fractions. So if you times both sides of the ratio by 10, that would be saying 50 to 20 would be exactly the same as 5:2. Then what we can do is we could double this side here, and then in proportion, if we double this side, 100 to 40 would be exactly the same ratio as 50 to 20 or 5:2. And now we can see if we double the 40 we'd get 80, so we'd have to double the 100 and we'd get 200 cakes sold. ABCD is a kite, and it says that AD is the same as AB. And we've got to find the smallest angle of that kite. Then an interesting fact would be to say that this angle was the same as this one. And if you think about it, if they weren't, we'd have a shape that looked something like this. And then what we'd have is that these two lines here would not cross at 90 degrees, okay? And I can exaggerate that a little bit more, so that would not be 90 degrees. When you have a kite and we put a line here, straight from D to B horizontally, we can then draw from C to A vertically, and they would cross at 90 degrees. And the only way that that can happen is if, especially if these lengths are the same, which it did say, that this angle would have to be the same as this one. So if we put 5x minus 147 equal to 2x, then if we solve that equation, we can add 147 to both sides to keep the balance, and we would have 5x equals 2x plus 147. We can then take 2x from both sides, and we'd have 3x equals 147. So x would be 147 divided by 3. So just think about what that would be. Well, 3 50s are 150, and therefore to be 147, you'd have to take one off each one 3 times. So it would be 3 times 49 basically. If you can't see that, then do 3's into 147, and we'd get 4 3's are 12 with 2 left over, and then 3's into 27 would be 9. So you'd get 49 degrees. So think very carefully, because sometimes these questions can trick you. If we did 2 times 49, that would be 98. And that's definitely not the smallest so far, because we said that this one is 116, which is bigger. If we did 5x minus 147, so if we did 5 times 49, we'd get 45, 20, we'd get 245 minus 147, and we know that that should be 98, because we've said that these two angles here would be the same. So if we worked out this as 98, we could have just put 98 there. So it looks as though that x would be 49 degrees, and we're thinking, maybe this angle is the smallest. But what would it actually be? Well, the last fact that we can use is that once we know that x is 49 degrees, we can say the angles in a four-sided shape, a quadrilateral, add up to 360. So we had 98, another 98, we had the 116 at the top. So if we add those up, and I'll do it in a column, then we'd have 16 and 6, that's 22, 18 and 1, 19, 20, 21, 1 and 2 makes 312. So that means 312 degrees has already been used up. So this one is actually 48 degrees, because only 312 and 48 makes the whole 360, which is what the internal angles of a quadrilateral has to add up to, because it's made up of basically 2 triangles and 2 lots of 180 makes 360. Question 16. Change 4,500 millimetre cubes into centimetre cubes. Well, let's have a look what a centimetre cube actually is. That means it measures 1 centimetre by 1 centimetre by 1 centimetre. Now, 1 centimetre is 10 millimetres. So the volume of 1 centimetre cube would be 10 by 10 by 10 millimetres cubed. So that would be 1,000 millimetre cubes. Okay, so that's 1 centimetre cube. So we've got 4,500 of these. So I hope you can see that that's 4.5 lots of 1,000. So if we did 4.5 centimetre cubes, that would be 4.5 times 1,000 millimetre cubes, which is exactly what we wanted. So here's our answer, 4.5 or 4.5 centimetre cubes. We've got to work out 2 3/5 minus 1 5/6. So let's see how this one can be in terms of fifths only. Well, 2 whole ones is 10/5 and 3 more fifths here. Well, that's 13/5. And here, this is in terms of sixths, so we've got 6/6 plus 5 more, which would give us 11/6. So we can't take these fractions away from each other until the denominators match up. So if we times this one by 1, i.e. 6/6, so it's like times the top by 6 and the bottom by 6, we would get 78/30. And then what we should do here is times this one by 5 top and bottom. And 5/5 is 1, and timesing 11/6 by 1 whole 1 doesn't change its value, so that would be fine. So we'd have minus 55/30. So our common denominator is 30ths, and how many, i.e. the numerators, is how many of them. So we've got 78 take away 55, which is 23/30. Question 18. It says that phone calls cost Y pounds for X minutes, and you've got a graph given here, and we've got to look at this graph, and firstly for part A, part I, we have to give an interpretation of the intercept. So let's zoom in on that a little bit. So it looks as here, when the x-axis is 0, i.e. when there's no minutes used, there seems to be a cost here of, in terms of pounds, £0.50. So we could say 50p. So that seems to be a standard fixed charge. So I would say that as a fixed charge. Now, what does it ask for next? It says, give an interpretation of the gradient of the graph. So I always go along 1 unit on the x. So this is nice to start from here. So I go along 1 unit here, and however much I go up is the gradient. So I've got to be careful of the scale. So that is 1, and that's a half there. So my interpretation would be, for every pound used, i.e. every one I go along on the x, it costs £1.50. Now that's always the case in terms of how I find a gradient. I always go along 1 unit on the x, and however much I go up or down would be the gradient. Don't forget, if it's going down after you go 1 along, the gradient's negative, i.e. the line is going downhill. So the interpretation of the gradient of the graph is how much the price, so I would say how much the price changes for each minute used. That sounds reasonable enough. Now, for part B, it says, write the equation of the straight line in the form y equals mx plus c. Well, you'll probably realise that this is the intercept, because if you put x equal to 0, this bit vanishes and you're just left with the y part is c. So when x is 0, i.e. here, the y value is 0.5. So we know c is 0.5. And when we have y equals mx plus c, this tells us how much the gradient actually is. So for whatever we go along 1, m is the multiplier. So basically it tells us what times table we're going up in. And we know that we went along 1, the multiplier would have to be, and m doesn't stand for multiplier, it means gradient, but it's like a multiplier. So I would say for every 1 unit I go along, I'm having to times by 1.5, because that's how much it's going up each time. So m is simply 1.5, and we had that here from this part, didn't we? So I would say y equals 1.5x plus 0.5. Some of you might prefer to say 3 over 2x plus a half. And incidentally, if you ever do have a fraction in a gradient, if you go along by the denominator, so if we went along 2, 1, 2, we'd have to go up by this number, and we actually do. So 1, 2, and then up 3, 1, 2, 3. So I'll do that again, along 2, up 3. So just for your revision, if you had a line that looked like 5 over 4x minus 5, then you'd have to go along 4 from a point that you knew, and you would definitely go up by 5 in this case. Alright, so just bear that in mind. It says ABCDE is a pentagon. It's an irregular one, it's not a regular one because not all the sides are the same. And it says work out the area of ABCDE. So when it says ABCDE, it just means, A, B, C, D, E. Right, so let's have a look. I'd probably split it like you would into a triangle and a rectangle. So the area of this rectangle is 4 by 8, which is 32 centimetre squares. And the area of this triangle, well, that's a bit more tricky, because we want to look at the base, and we know the base is 8 centimetres, but how would we work out the perpendicular height? Well, if we had to look at, say, this triangle here, T1, it's right angled. This is the height we require. This is 5. This would be 4. And so h squared plus 4 squared would be 5 squared. So basically h squared plus 16 is 25. So h squared would be 9. So h would be 3. So 3 centimetres. And so we can do the area of this triangle by doing base. So the area of triangle is base times height over 2, where height is the perpendicular height. So we'd have 8 times 3 divided by 2, which is 24 over 2, which is 12 centimetre squares. So altogether our total area would be 32 plus 12, which would be 44 centimetre squares. Question 20. It says on Monday Tarek travelled by train from Manchester to London, and it gives some details about when Tarek's train left. It left Manchester at 8:35 in the morning and got to London at 11:05. It says the train travelled at an average speed of 110 miles per hour. So I think the first thing to think about is, if we want to start looking at Jill's travel, is to work out the distance between Manchester and London first, given from this information. So from 8:35 in the morning till 11:05 in the morning, that looks to me as being 2.5 hours. So let's put that as a decimal, 2.5 hours. And if it's going at 110 miles for every hour, then we just got to do 2.5 times 110 to work out the total distance. So 2 lots of 110 is 220, a half of 110 is 55, so that's 275, and that is miles. Now this question's getting me thinking. So Jill is going from Manchester to London, so it's the same journey, but there's a little bit of a diversion, so there's 37 extra miles. So that means Jill must have travelled what Tarek did, which was 275, plus another 37. So that is 312 miles. And what we can then see is that it took her from 8:35 in the morning to 11:35. So that took 3 hours. So if we think about the thing that we don't know, or we can't work out from this, is the actual average speed. Not straight away anyway. We just know it was 312 miles per 3 hours. So 312 thirds, well, 312 divided by 3 is 104 miles per 1 hour, and that's what we want. So her average speed was 104 miles an hour. Tarek's average speed was 110 miles an hour. We've got that here. So the difference would be 110 minus 104, which is 6, and I'll just do mph, 6 miles per hour. So for those of you that aren't completely familiar with distance per time, this per part here just means, for example, if I said 3 kilometres per hour, it's like saying 3 kilometres divided by 1 hour. And this is called the units, so it's kilometres over hours, which is kilometres per hour. So PER is like having a dividing line in there. So it can be confusing to some people, but really handy if you can make it a fraction, because you can always make this denominator 1, i.e. whatever the top number ends up to be is how far you've travelled per unit of time. Question 21. The diagram shows a rectangular wall, and Frank is going to cover the wall with rectangular tiles, and it says that each tile is 60 centimetres by 30 centimetres. Now, if we draw a diagram of the wall here, and we'll convert to centimetres, so this will be 600 centimetres, and this would be 180 centimetres, then we can see here that we'd have a tile would be 60 centimetres by 30 centimetres, so it probably look more like this actually. So there we go. Then how many would we be able to lay across here? Well, if we started laying these tiles across, then we'd have 10 this way, and if it measured 30 in terms of the width, well, how many 30s would go into 180? Well, there'd be 6 rows of 10 tiles. So we can definitely work out that there'd be 60 tiles to begin with. So the next thing we'd have to work out, and of course you'd lay your work out better than this, it's just I'm laying this out so I can explain it to you. So 3/5 of the tiles, so 3/5 of 60, and you can either do this as 5 into 60 is 12, times 3 is 36, or 3 times 60 is 180, divided by 5 is 36. So you can work out there's going to be 36 white, and then it says some of the tiles will be green and the rest of the tiles will be blue. So here's our next bit of information here. It says the ratio of the number of green tiles to the number of blue tiles is 1 to 3. Well, if we recap over what we've already got, we've worked out that there was 36 white and there were 60 tiles altogether. So we can see that 60 take away 36 leaves us with 24 tiles of differing colours, i.e. green or blue. So the ratio is 1 to 3. So how many parts is that? Well, it's 1 part and 3 more. So it's 1 and 3, that's 4 parts. So if we divide the 24 by 4, we get 6, and that would represent 1 part. Well, how many parts are green? 1 of them, so there'd be 6 green. And how many parts represent blue? 3 of them. So 3 lots of 6 is 18. And just double check, does 6 and 18 make 24? Yes, it does. So we're ready to put our answer in here. We've got 36 white. We'd have 6 green and 18 blue. Part B says, if Frank leaves gaps between the tiles, how could this affect the number of tiles he needs? Well, if it was 60 tiles with no gaps, then basically if you had to have gaps, then you wouldn't need as many tiles because there'd be a lot of the surface area taken up by gaps, not so much tiles. So you were just right, fewer tiles would be needed. Question 22. It says on Monday, Ria delivered a parcel to a hospital. The travel graph represents Ria's journey to the hospital. It says Ria left home at 1300 hours, so we can label that here. And she drove for 30 minutes at a constant speed of 40 miles per 1 hour. So if you see here, this is going to be representing the 30 minutes. So this will be 13:30 by this time. And if we read up here, this should tell us the distance because that's the distance axis. So 40 miles in 1 hour, if we halve top and bottom here, we get 20 miles in half an hour, or the 30 minutes is required. So we know that the distance travelled was 20 miles. And we can just label this axis here, 5, 10, 15, 20, 25, 30, 35, 40, and so on. The next part of the travel graph says she stopped for a break, so she would have stopped for a break for another half an hour because that's what this axis is going up in. So it's going up in 15 minutes for each part here of the graph. So this would be 2 o'clock here, so that would be 1400 hours by the time we get to there. So we label the rest of this, so that would be 1430, and this would be 15, 1530, and then 16, and then 1630 here. So Ria then drove to the hospital at constant speed. So there we go here. Doesn't ask us to work out anything else from here. So we don't need to worry too much about that. And then it says she was at the hospital for 30 minutes. So if she was at the hospital, then she wasn't moving in terms of driving rather. So 30 minutes would be to here. Okay, going up here, 30 minutes. And here's the crunch. It says, she then drove home at a constant speed of 32 miles an hour. Show that she does not arrive home before 16:30. So if she went at a constant speed, then what I would do is I would draw a line, and I'll try and draw this in a different colour. And I would say, if she wanted to get home, she'd have to abide by how this gradient looks here. So all we've got to work out is what that means. Well, from here to here is a gap of 1 hour. And what's the distance travelled? Well, it's 5, 10, 15, 20, 25, 30, 35, 40. So you'd have to have gone at 40 miles per hour. And she only went at 32 miles per hour. So you'd write your explanation and you'd say 32 miles an hour would not be quick enough or fast enough to get home in that time, as shown by the travel graph. So you can see my explanation here. I've just said the red line shows that 40 miles per hour would be the required speed. Ria does not go fast enough at 32 miles per hour to get back in time. Okay, and there's plenty of ways of doing that. You can just do a little label here and write your explanation here, for example, as long as you make it really clear what you're doing. A number y is rounded to two significant figures and the result is 0.46. So 2SF, two significant figures. So we want to see the error interval for y, basically how high that number could be and how low that number could be. So both numbers should round to 0.46. Well, what I normally do is I look at the place value it's been rounded to. So it's been rounded to two significant figures, or in this case, the nearest 100th. And I take the number 100th as a decimal, and then I halve it. And that gives me 0.005. So all I have to do is add 0.005, which would give me 0.465, and then I take 0.005, and that would give me 0.455. Now, this would be my lower bound, or the lowest that this could be, so I'll write that here. Because if you look at 0.455, if you were to round this to two significant figures, this 5 would make that one a 6, and that would give 0.46. This one here, however, if we took 0.465, this 5 would round this to a 7. So it couldn't quite be that number, so it would be everything up to that number, but not quite 0.465. So what you would say is, you would say 0.455 is fine, so it could be that number, or anything more than it. However, it would be everything up to 0.465, but not quite exactly 0.465. So for example, 0.4649999 and so on, or 0.4649 recurring. So that would be what I would put in this exam. Some of you may disagree, but I hope that is some explanation. Question 24. Write 360 as a product of its prime factors. Well, let's just get the multiplication. 36 times 10, for instance, you could have done 18 times 20, or any multiplication that gives 360. Then all you have to do is just break any of these numbers down into prime numbers. So that's 2 times 5. 36, that's 6 times 6. And then the 6's, that's 2 times 3 times 2 times 3, and so on. So that would be fine, but if we want to see how many powers of 2 we have 3 powers of 2, so 2 to the power 3, 2 powers of 3 times 5. So that would be just as good as for the answer. Here's one more way. You could do, I don't know, let's say 90 times 4, because 4 right angles make 360 degrees. Split the 4 down into 2 times 2. Split the 90 into 9 times 10. Split the 9 to 3 times 3, so there's our 2 powers of 3. Split the 10 into 2 times 5. And there's our 3 powers of 2 and our 1 power of 5. So there's plenty of ways of doing that.